Well, hello all. I want to go through the South African Physical Science Paper 1 of November 2024. And this is what the best and the brightest in South Africa are busy with. So let's just quickly look at the first question. Is they drag a block along the table with a weight and they see what the acceleration is. In the second problem, they have, let's just see if we can get the second problem. They throw two stones off a building and then they try to find out the height of the building and the time it takes the stones to land on the ground simultaneously. Let's have a look at the third question. The third question, which is actually question 4, or the third topic, is they put a spring between two trolleys and trolley B goes up a certain height. This is going to be a conversion. Momentum's conserved, then energy is conserved. The potential energy at the top is equal to the kinetic energy at the bottom. So they're springing two trolleys apart. This is the best and the brightest in South Africa. This is what we trained them for 12 years to do. And then the next thing is another dragging of a block, a crate, no, along the ground. And so instead of dragging a block, we're dragging a crate now in question number 5. In question number 6, we've got Doppler, which is we've got a sound of a police siren as you hear it and as it actually is. And if it's moving towards or away from you, if it's towards you, the pitch gets higher. If it's moving away from you, the frequency gets lower. So it's got a police siren, and they train to be able to work out the speed, for example, that the police car is going from that. In the question number 7, or the 6th topic, they've got a couple of little charges and they work out the field at a distance of 6 centimeters, and then at 4 centimeters they work out the field. No one ever works with little point charges because it's almost impossible, and this has got absolutely no application in real life. The only time you deal with charges is in capacitors in electronics. So anyway, they're playing theoretically. None of this ever do they do in practice. I mean, no one has ever done that in practice. Now here in the next question, they've got a totally impractical circuit. They've got some sort of battery with an internal resistance, a resistor here, and then they've got two components that have got a certain power, and from their power you've got to work out what's the current through them, and the voltage, they've got a certain voltage. So a totally impractical circuit, but I do like it. This is probably the most worthwhile thing this is perhaps the only thing that they'll ever use, but no one ever in real life uses a circuit like this. No one ever. This is just not a practical circuit. It's a theoretical circuit. It's like everything else that these people do. It's all theory. You see, they've got to find out the reading on the ammeter A, a wire 2, and number 1, the resistance of resistor 1, and the EMF of the battery. Okay, I don't criticize that question. I think people need to know. I mean, we need to work with electricity. We've got Eskom, our power company, that fails all the time. So here's a question on generators. And when you get this kind of thing, it's a DC generator because it stays positive. If it's AC, it would do this. There's one full rotational cycle. So they show you the wave, and then they ask questions on this theoretical generator. Again, South Africa needs to generate electricity. So they've obviously increased the period of the generator, or they've turned it slower. And then they're going to ask questions on that. And the final question is they shine red, blue, and green light onto a potassium sheet. Well, totally theoretical. This is not like you actually use. This has got to do with solar panels. So if you shine blue light, it's got more energy than green, and then red is the least energetic. So in theory, they just talking in theory about how photons will knock off electrons, and you'll find that the blue and the green knock off more photons and the red won't, because it hasn't reached its threshold frequency. And that's the paper. 10 well, it's actually 9 topics that are covered. Now, ask yourself, the best and the brightest in South Africa spent 12 years, and this is what they've got. How is anyone going to go out from school and earn a living in the sciences knowing how to pull a trolley along a desk, then you pull a crate at a slight angle along the ground, and then you spring two things apart, or you listen to the frequency of a police siren, and this is totally impractical. Our police sirens go wow, 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 wow. In their theoretical siren, it goes. It's a one siren police siren. It's not practical at all. And where does Doppler work? I mean, where is Doppler important? Doppler could be important in, if we're going to discuss the redshift of the universe, which I do have a little bit of a question on. I mean, that's the only interesting part there, how Doppler plays a role in our expanding universe. But, and then playing with charges. No one ever plays with charges. It's worthless. It's got zero value in real life. Then they've got a totally impractical electrical circuit, and then they've got a theoretical, not anything to do with actually getting a solar panel, and then you get your charge controller, and then you get your battery storage, and you get your inverter, and how you could wire this all up and use it practically in South Africa. Folks, we have turned out people who have never used these little fingers to ever do anything practical for 12 years. It's all up here. We just cultivating the mind. Then we send them out into the world. 50% of them can't find jobs of our matriculants. Maybe these guys will go to university, some of them. The rest of them will find that all the 12 years of learning this shit, this stuff, is not going to help them in the least in their actual life. So we've taught them for 12 years stuff that's totally impractical. They're never going to be able to use this in their actual own life. And then all the problems that South Africa has, none of them are going to get solved by this. Of the whole universe of laws and usefulness of physics, physics can be used to fix anything, do anything, create magical solutions to problems, this and that. Oh, it's a wonderful, interesting subject. Of it all, we've chosen these topics, and you know what? Amalusi, who runs this, the South African Education Department, is going to come out and say, we had an 80% pass rate. It was better than last year. We're wonderful. They'll have a love fest of patting each other on the back and thinking, wow, we've done a fantastic job with these students. And you know what you've done? You've had this uninteresting, useless physics, which they've never touched. They don't dirty their hands to do any of this, any of it. Not anymore. In our day, we used to. That's why we were interested in physics. We could see the practical use of physics. This has all become theoretical. You can't actually do these things in schools, and probably they'll never do this. And it's useless to do it. So with all the millions of problems that could be solved in South Africa, we are sitting doing this, twiddling our thumbs while South Africa burns.